Hey everybody, and welcome back to another session with the Dr. Coolcat team. Today we are diving into something that pops up all over the GD science test and, let's be honest, can be a little tricky. Scatterplots. But stick with me because we're about to turn them into a total easy win for you.
You ever see one of these on a practice test and your brain just kinda freezes? It can look like just a random, chaotic mess of dots. But I promise you, by the end of this explainer, you're gonna have a super simple, powerful strategy to look at any scatterplot they throw at you and know exactly what to do. No more guessing.
Okay, so here's the secret weapon. We call it the dots to line routine. Think of it as your 7-second game plan. It's a really quick, two-step process that'll let you break down any scatterplot and figure out its story in, well, seconds. And it really is that simple. First, we start with dots, just a quick glance to get the big picture feel for the whole cloud of data. Then, and only if we see a clear pattern, we zoom in on the line to really analyze that trend. This little trick keeps you from getting bogged down in the tiny details right away and helps you find the main idea fast.
So, let's break down that first step, reading the cloud, or dots. This is your initial super fast scan. Seriously, we're not doing any math here. We're just getting the lay of the land, kind of like a detective sizing up a crime scene.
First up in our dot scan is direction. Just look at it. Which way is that cloud of points leaning? If it's kind of sloping up from left to right, that's a positive relationship. If it's heading down, that's negative. And if it's just a big random blob, well then there's no clear relationship. That's your first major clue. Next, you want to look for any rebels in the crowd. See a dot that's way off on its own, far away from the main group? That's what we call an outlier. You don't need to do anything with it yet, just make a little mental note. It could be a mistake in the data, or it could be a really interesting story. For now, we just notice it.
Okay, now, how tight is the group? Imagine you're trying to draw an oval around the whole cloud of dots. If you can draw a really tight, skinny oval, that's a sign of a strong relationship. But if the dots are all spread out and your oval is kind of fat and round, that means the relationship is weaker. It's a quick visual check on how strong the connection is.
And last, for our dot scan, check the shape and scope. Is the pattern basically a straight line, or does it have a curve to it? And here's the sneaky part that catches so many people. Take a quick peek at the numbers on the axis. What's the actual range of the data? This is so important because, as you'll see in a minute, you can only talk about the data you can actually see.
All right, so once we've done our quick dot scan and we've confirmed, yep, this looks like a pretty straight line, we can move on to the second part of our routine, line. This is where we get a bit more specific and start making some actual evidence-based claims about the data. So how do we put a real number to that trend we're seeing? We use the slope formula. It looks a little scary, but it just tells us the rate of change. Now here is probably the most important tip in this whole explainer. That number you calculate is completely meaningless without its units. Is it 2 points per hour? 2 degrees per minute? $2 per person? The units are everything. They're what tell the story. Okay, let's make this real. Imagine you see this scatterplot on the GED. Along the bottom, you have the number of hours a student studied, and at the side, you have their final score on the science test. We can definitely see a trend going up, so let's use our line analysis to figure out exactly what it's telling us. Okay, so let's say the trend line on the chart goes right through 2 helpful points, one at 0 hours of studying for a score of 65, and another at 10 hours of studying for a score of 85. Let's plug those into our slope formula. We take the change in the score, so 85 minus 65, that's 20. Then we divide that by the change in hours, 10 minus 0, which is 10, and 20 divided by 10 gives us the number 2. But 2 what? Don't forget the units. It's positive 2 times points per hour of study. See how that tells a story? And this, right here, is the absolute perfect way to phrase your conclusion on the GED. Look how careful this language is. It says, in this sample, because we can't speak for every student in the world, and it says, tended to, because it's just a trend, not a perfect, unbreakable rule. We are not saying studying causes high scores, just that they're connected in this set of data. This precise, safe language is exactly what the test makers want to see. So before we jump into some practice, let's get inside the minds of the people who make the test. They love to set a few common traps when it comes to scatterplots. If we know what they are ahead of time, we'll never fall for them. This is the big one. Everybody say it with me. Correlation is not causation. Just because two things happen together doesn't mean one is making the other happen.
The classic example is ice cream sales and shark attacks. They both go up in the summer, right? But eating more ice cream doesn't cause shark attacks. There's a hidden factor, the hot weather, that's causing both. So on the test, always stick with safe words like is associated with, and run away from risky words like causes or proves.
And the second major trap is something called extrapolation. Let's say a chart shows that adding fertilizer helps plants grow, and the data is for doses between 0 and 15 grams. Estimating the plant height for an 8-gram dose, that's called interpolation, and it's safe because it's inside our data range. But guessing the height for a 30-gram dose, that's extrapolation, and it's a wild guess. For all we know, 30 grams of fertilizer might kill the plant. You have to stick to what the data actually shows you.
All right, you've learned the DOTs to line routine, and you know the traps to avoid. Now it's your turn. Let's put this all together with a practice question. Okay, so picture this, a scatter plot, where the bottom axis is the daily temperature, and the side axis is the amount of heating energy a building uses. You do your quick DOTS scan, and you see the points are sloping down. So as the temperature goes up, energy use tends to go down. Makes sense. Now, based only on that trend, which of these statements is the safest, most supported claim you can make? Take a second and think about it. Let's walk through these. Answer A has that risky word cause and says everyone. That's a huge claim, so that's out. C is just a wild guess with no evidence. D is classic extrapolation. Our chart probably doesn't go to 100 degrees, so we can't say for sure. That leaves us with B. And look at that perfect, safe language. In this sample, tended to be. It just describes the relationship we see. That's our winner, hands down.
And here it all is, your complete dots-to-line cheat sheet. Every single time you see a scatter plot, just run this mental checklist. First, your quick scan, dots. What's the direction? Any outliers? How's the tightness? What's the shape and scope? Then, if there's a trend, you move to line. Find the slope, interpolate only, name your units, and state your evidence with careful language. This is your path to the right answer every single time.
And that's really it. So, congratulations. That confusing mess of dots from the beginning of our chat, it's not so bad anymore, is it? You now have a powerful, step-by-step strategy to make sense of it all. This is going to be a massive confidence booster for you on Test A.
So, I have a question for you. Now that you know the traps, what's the #1 thing you're going to be watching out for? Was it that tricky difference between correlation and causation? Or was it the temptation to guess what happens outside the data range? Drop a comment below and let me know which of these traps was the biggest aha moment for you.
And hey, if this explainer helped you out, do us a favor and hit that like button. It really does help us a lot. And of course, be sure to subscribe for more test-taking tips and strategies from the entire Dr. Cool Cat team. Thanks so much for watching, and we'll see you in the next one.